Hello friends, I am Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today our topic of discussion is the introduction to determinants of a matrix. So friends, I told you that today we are going to discuss about the determinants of a matrix. That means determinants is something which is related to a matrix. Now, not every matrix has determinant value. Here we have to take square matrix and we have to discuss the determinant of a square matrix. So, the definition says that every square matrix A is associated with a number and that number is called determinant. So, a number which is associated with a square matrix is called its determinant. Now, the determinant of a matrix A is shortly written as or denoted as det of A. Det is the short form of determinant, or we can put two vertical bar brackets here to represent the determinant of a matrix. Sometimes some books are also using the symbol delta or del to represent the determinant of a matrix. Now, let me clear you again that only square matrices have determinants and the matrices which are not square do not have any determinant. Now, determinant of a square matrix, say A1, B1, A2, B2, which is a second order square matrix, its determinant is written by the symbol. The same elements are written in their own respective positions, but the bracket is changed. Beside writing the round brackets or square brackets which represents the matrix, now we are using its determinant value as within two vertical bar brackets. So, two vertical bar brackets represents the determinant value of the square matrix given to you. So, be careful while using these brackets. Round or square brackets represents matrix, where vertical bar brackets represents determinants of a matrix. Now, another important thing here is the order of the determinant. So, the order of the determinant is almost same as the order of a matrix. So, order of a determinant is nothing but the number of rows or the number of columns of that matrix, because it is a square matrix. Now, let us discuss the determinant of different matrices according to their order. So, let us go for the first order determinant. So, a first order determinant is the determinant value of a first order matrix. That means, a matrix which has only one row and one column. So, let A is a matrix which is of first order, that means, it has only one row and one column, that means, only a single element it has. So, the determinant value of this matrix A is equal to its own element, single element. Example, say A is a matrix of element 3 only. So, the determinant value of this matrix is also equal to that element 3. Now, come to second order determinant, that means, say A is a matrix which is of second order, that means 2 by 2 order matrix, and the elements it belongs are A11, A12, A21, A22 row wise. Then the determinant of this matrix A is written by vertical brackets and which is equals to the subtraction of the product of the diagonal elements from left side to right side. That means, you multiply the left side diagonal elements A11 with A22 and from that you subtract the product of the right side diagonal elements, that means, A21 with A12. So, A11 into A22 minus A21 into A12 is equals to the determinant value of this second order matrix. Now, before moving for third order determinants, let us discuss some important factors that are required or that will be used while discussing those values. So, in that way, first discuss minors of a determinant. Now, the word minor you know minor is something which is less than. Now, what is less here? Here we are discussing the determinants in terms of their order. So, that means minor of a determinant means another minor of a determinant is another determinant which is one order less than that the original determinant. That means, if I have a determinant of third order, then the minors of the third order determinant will be minors of second order determinants. The minors of a third order determinant will be equals to the determinants of the second order determinants, and the minors of a fourth order determinant will be the determinants of third order that are collected from that original determinant. Let us try to understand them. The minor of any element of a determinant is the determinant which is obtained from it by deleting the row and the column in which the given element occurs. So, let us take a determinant, and in that determinant let us there is an element a I j, and I have to find out the minor of that element a I j in that determinant. Symbolically, I will write them as m I j. The minor of a I j is written as m I j. So, the minor of any element in the third order determinant is a second order determinant, as I told you before. To understand this further, let us take one determinant of third order. You can see the elements a11, a12, a13 and so on. So, the minor of the element a11, which is symbolically written as m11, is nothing but the determinant of second order, which is obtained by removing the row and column to which the element belongs. So, a11 which belongs to the first row and first column. So, if we remove the first row and the first column, then the elements that are remaining are a22, a23, a32 and a33. So, that determinant which is of second order determinant is the minor of that element a11. Now, you can further calculate it by cross multiplying and subtracting, as you know before. Similarly, the minor of the element a22 will be a second order determinant which is obtained by removing the row and column it belongs. A22 belongs to your second row and second column. So, let us remove them and you will get another determinant which belongs to elements of a11, a13, a31, a33, and you can so on calculate the minors of each and every element of a determinant by removing its row and column. So, friends, we come to know that minor of any element of a determinant is another determinant of one order less, and that is obtained by removing that particular row and column to which that element belongs. So, let us come to know another term here, that is the cofactor of a determinant. I will tell you, friends, why this word cofactor is used, why this is named so, but let us try to understand first what is cofactor. So, the cofactor of an element is equals to its minor with appropriate sign. So, there is very less difference, very small difference between minor and cofactor, and that difference is only of sign, that means of positive or negative. So, that means if there is a minor and you will change the sign of that minor, then you may get its cofactor, but that changing of sign depends on a particular formula. So, the sign is positive if the row and the column number of the element add up to an even integer. If you will add the row and column number to which that element belongs, and if the sum of that row and column number is even number, then there is no change of sign in the minor to get the cofactor. But if the sum of the row and column number of that element is an odd number, then by changing the sign of the minor of that element, you will get its own cofactor. That is better understood by this simple formula. So, the cofactor of the element Aij is symbolically written as Cij, which is equals to minus 1 to the power I plus j. I told you I is the row number and j is the column number, multiplied with its own minor Mij. So, cofactor of an element may be equals to its own minor, or by changing some sign you will get its minor. It depends on the sum of the row and column number. If I plus j is even, then this will become positive. So, cofactor is equals to minor. But if I plus j is odd, then a minus sign will come here and the cofactor is equals to the negative of the minor. Let us try to understand this by taking one third order determinant. This is a third order determinant where the elements are row wise are A11, A12, A13 respectively. So, the cofactor of the first element A11, which is symbolically written as C11, is equals to, by the above formula, it is minus 1 to the power 1 plus 1 into the minor M11. Now, minus 1 to the power 1 plus 1 means minus 1 to the power 2, which is positive. So, this will not change the value of the minor, and the minor M11 is obtained by removing the row and column to which A11 belongs. So, the minor we are getting here is a determinant of A22, A23, A32 and A33, that you can multiply, cross multiply and subtract, and you can get by expanding. Similarly, the cofactor of another element, let us take say A23. The cofactor of A23 is symbolically written as C23, which is equals to minus 1 to the power 2 plus 3 into its minor of that element to A23 is M23. Now, we know minus 1 to the power 5 is negative, and the minor M23 is obtained by removing its row and column, that is a determinant of A11, A12, A31 and A32. Now, you can calculate it further and you can get the cofactors. So, this is the process of getting cofactors and minors of the elements of a determinant. Now, to remember the sign of cofactors of the elements of different order determinants, you can remember by this way, so that it will help you to quickly calculate. Beside adding the row and column number, you can add, because up to maximum third order determinants we are going to use for our calculation now. So, a first order determinant has only a positive sign for its minor, for its cofactor, sorry, and second order the signs will be left diagonal it will be positive, right diagonal it will be negative, and third order, which is of important, here you can see diagonal elements, their sign of their cofactors outside the minor will be all positive, and non diagonals are negative, they carry negative signs. So, this will help you to quickly calculate the cofactors from its minors by changing the sign accordingly. Now, friends, let us discuss the evaluation or expansion of a third order determinant. Before that, we discuss how to find out the determinant value of a first order and second order determinant. Now, let us discuss the third order determinants expansion or evaluation. So, for that we have two laws here, one is the Laplace rule and second law is Sarra's rule. Now, the difference between Laplace rule and Sarra's rule is Laplace rule is a general law, it is applicable for any order determinant, that means Laplace law can be used on fourth order, fifth order and so on. But Sarra's rule is a particular rule which is based on or which is applied on only third order determinants. It is a special rule. So, let us discuss the general rule Laplace rule, which is, for that let us take a matrix A, which is a third order matrix containing 3 rows and 3 columns. The elements are taken as usual, you can see. Now, what the Laplace rule says that? A Laplace rule says that a determinant of higher order is evaluated by expanding the determinant by the elements of any row or any column as the sum of the product of the elements of the row or column with the cofactors of the respective elements of the same row or column. That means, you can calculate the determinant of this matrix A with the help of any particular row or particular column. But for that, you have to first of all choose a row or column. Say you are choosing the first row. So, the elements on the first row are A11, A12 and A13. So, what you have to do? You have to multiply the elements of this first row with their own cofactors, and then you have to add them, add the 3 products, and the result will be the determinant of this matrix A. That means, A11 with multiplied with C11 plus A12 multiplied with C12 plus A13 multiplied with C13 will result in the determinant of the matrix A, and that the same process you can adopt with any row or any column. It does not matter which row or which column you are taking, but the result will be always the same and a fixed number, and that number is the determinant value of this matrix. So, that is why it is called that determinant is a number which is associated with a square matrix, because it is such a fixed number that is obtained with the help of any row or any column. So, let us try to understand it with few examples and few expansions. See, I have written here for you, if I am choosing the first row in that matrix, the elements are A11, A12, A13, I am multiplying their respective cofactors with them, and I am adding the 3 products, and I am getting the determinant of A. If I will use, or if I am choosing the third column, for example, so the third column elements are respectively A13, A23 and A33. So, you multiply their own cofactors with themselves, that means A13 multiplied with C13 and A23 multiplied with C23 and A33 multiplied with C33, and you add the 3 products, and the result will be again the same and that fixed number, and that is equals to the determinant of the matrix of which this elements belongs. So, this is a very beautiful law which is applied for any order determinants. Let us try to discuss this through one example. I have taken this determinant of which I have to find out, I need to find out the determinant value. So, I want to find it out first of all by using first row. So, using the first row, let us find out the determinant of this value of this determinant. So, the first row elements are 1, 2 and 3. So, first element 1 with its own cofactor. Cofactor is obtained by removing its row and column, the determinants you are obtaining, and the sign of this first element is positive. Then the sign of the second element is negative according to its cofactor, and the sign that you will use in the third position according to its cofactor is positive, positive, negative, positive. So, it will be 1 into its cofactor plus 2 into its cofactor which contains negative outside, then plus third element 1 into its own cofactor which is also positive. Then you can further calculate it by expanding this 2 order determinant, and you can find the value as minus 5. So, the determinant of this, the value of this determinant is minus 5. So, this shows that the determinant of a matrix, the value of the determinant can be negative, positive or 0 or any fraction or anything, depends on the elements that we are taking inside, it can be anything. So, let us try to verify that whether it is working for any other row or column or not. For example, let us take the second column. In the same determinants, let us find the value using second column. So, if you will find the value according to second column, first recall the sign that I told you in the previous page, that the second column elements are 2, 1 and 4, and the sign of their cofactors are negative, positive and negative. Okay, friends. So, you multiplied the element 2 with its cofactor which carries negative outside, and adding with multiply 1, the second element 1 with its cofactor which is positive by sign, and the third element which is 4 here with its cofactor which carries also negative. Now, you expand them and calculate them and you get the same result, that is of -5. So, this shows that you can apply the Laplace law in any row or any column, it does not matter, the value will be always the same, and that same value is nothing but the determinant of that matrix or the value of the determinant. So, this Laplace law again I am telling you can be applied on any order determinant. This is general law. Now, come to that particular law which is called Sarra's rule, which is applied or applicable only on third order determinant. So, let us try to understand it. If A is a third order matrix as I taken before, then the determinant of that matrix A can be formed by enlarging the matrix by adjoining the first 2 columns of the on the right and draw lines as shown below, parallel and perpendicular to the diagonals. So, how to recall this law? You can see there are 3 columns in this matrix. What you have to do, that you take out the first 2 columns and again write them on the right side of that third column in any row or on the one side of that paper. See, first column, second column, third column, then again the first 2 columns are repeated here on the right side of the third column. Then starting from the first element moving diagonally, you multiply the elements parallelly. That means, you multiply A11 after writing the 2 columns again, repeating the 2 columns again on the right side of the third column in a paper. You start with the top corner, left corner elements and multiply the elements moving diagonally and parallelly. You will get 3 different products. First product will be A11, A22, A33, find the product. Then the second product will be A12, A23, A31, write it down. Then the third product will be A13, A21 and A32, find the product and add these 3 products together. Then you repeat the same process from the right side corner, right side top corner. You have done this plot from the left side top corner. Now, you repeat the same process from right side top corner, that the right side top corner element is A12. From here you move diagonally, multiply 3 elements and parallelly you go and multiply elements 3, add them together and this total, this right side product total you subtract from the left side product total, and that is nothing but the Sarra's rule, which is very easy to calculate also. Let us discuss them through this example, simple example. I have to find out the determinant of this, the value of this determinant. Now, on one side I have written the 3 columns as they are, then I have repeated the first 2 columns on the right side of the third column. Then I can start from the left side top corner and move diagonally and multiply the elements, and the products are 1, 1, 2 added with the next parallel diagonal products 2, 3, 1. Then the third diagonal parallel products are 1, 2, 4. So, you multiply these 3 elements and add them together in a bracket, and this one, from that you subtract the right top corner elements diagonal products and moving parallelly you add them. That means, 2, 2, 2 you multiply and add with next parallel product diagonally 1, 3, 4, then with that you add the next parallel diagonal product 1, 1, 1, and you can, by multiplying and adding and subtracting, you can get the value, you are getting the same value. So, knowingly friends, I have taken the same determinant as I have used in Laplace, and in case of Laplace we get the determinant of this, the value of this determinant is minus 5, and you can see by using the Saras rule also we are getting the same result, minus 5. This shows that both Saras and Laplace are workable, and you can use them according to your own comfortability. So friends, this is all in your introductions and calculation of determinants. I hope you understand this topic. So friends, if you like this video, please subscribe this video, and thank you very much for watching.